Good morning, my fabulous chemistry students. Unit number 7, solutions. Today we will do the first video. We will compare heterogeneous and homogeneous mixtures, okay? And we'll get into some definitions. Before we start, I just want to clarify a few things. I understand you're going to have to listen to me and stare at the screen. You don't have to take any notes, but it's important that you hear what I have to say. First thing, this unit is going to go fairly quick. A lot of it's going to be definitions at first, and then it's going to kind of culminate everything we've learned to this point. Okay, you're going to have to be able to use a lot of what we've learned in this unit. The last piece is, while I'm talking, especially on that last slide, these notes for you are going to be designed to guide you into what your next tasks should be when you're done with the notes. So please pay careful attention at the end of the notes as we go on. The first 2 notes videos or so, not so much, but then when we start getting CASEL assignments, you're going to want to pay closer attention, and the CASEL assignments have changed a little bit. So that being said, let's get into it and keep this down as far as time-wise. We have heard the term solutions, of course, and how it pertains to liquid mixtures. We need to do a little bit of vocabulary to make sure that we're all on the same page as far as chemistry goes. So let's get right into it. A mixture is a combination of 2 or more pure substances that can be separated by physical means. Okay, physical is like filtering. Number 1 is filtering. Think of sand and water. I can get the sand and the water to separate if I filter it. Okay. A heterogeneous mixture is 2 or more pure substances in different physical states, varying composition, not uniform throughout. So this different physical states, I don't know so much I believe in that, because I could have 2 solids, right? I could have pebbles and I could have sand. Okay, and they're definitely different. Okay, but they're both solid. This varying composition, not uniform throughout, is the key. Okay, so a suspension is a heterogeneous mixture that clearly separates. So here's the sand, the clay, and the water. You shake it up for a second. It looks like it's all one thing. You set it on the table. You let it sit for 5 minutes. And as it sits, you'll see the things start to settle out, and they'll go by density, okay? So they'll eventually separate upon standing. They don't visibly dissolve. Nothing visibly dissolves in the water like salt water would. All right, I can separate it by filtration. I have relatively large particle size. Think of sand and water or Italian dressing. Okay. Next one is one that's tough to remember. It's called a colloid. A colloid is not clearly separate, but it does look like a solution at first, and we have to do some special tests to find out that it's not. It could be cloudy. Okay. I need to use basically a centrifuge to separate the stuff out. All right. The particle size is going to be medium to small, and the properties in between a suspension and a solution. So think of blood or milk. Basically, they can be clear. I think we get into this in the next page. Clear doesn't mean they're colorless. Clear just means that, see, I can kind of see through it a little bit, but they'll be cloudier than not. And we're going to use the Tyndall effect to tell if it's a colloid or not. Okay. Homogeneous mixtures, aka a solution. Same physical state. So not different physical states in this time, same physical states. It's all liquid. Okay. When I say that this particular sample is clear, this one is not as cloudy as the ones on the previous page. It does have color, but I can see through it. Nice and easy. It's transparent. So that's what we mean by clear. It can be colored, can be colorless, but it's very clear or transparent. Okay. This means our particle size is so small we cannot see them. It will not show up in what we call the Tyndall test, which we will learn what that is. So now we think of salt water, Kool-Aid, or club soda. Okay. Get right through this first set of notes that's just basically all definitions. Now an alloy, we've heard of this before. It's generally a mixture of 2 metals, okay? But at least has to have 1 metal in it. So carbon and steel is essentially an alloy. We're going to take carbon and iron to make steel, okay? The metals arrange in a pattern with a sea of mobile electrons. Sorry, we can't see this electrons, right? But we know it's definitely electrons. Let's get it down there. A sea of mobile valence electrons, gluing them together. Examples, common ones, brass, which is zinc and copper, and steel, which is iron and carbon. Okay, when I take two metals and put them together, or at least one metal, then we're calling it an alloy. I've heard that a lot of times with alloy rims, right? So here's the first end page for this unit. You should be able to now tell me the different combinations of materials and define what they are: colloid, solution, suspension. Okay, and we have physical practice for you guys to do with this. There's nothing in the practice packet to do, and there's no quiz on Castle Learning to do, so we are done with this particular assignment. I wish you well, study hard, and please pay attention in future videos to this particular slide, because things are going to be a little bit more cut and dry. I'll give you a little bit more information about what you need to do next in future videos. See ya.